To this barrier, all living organisms on Earth are protected. Some particles move along the magnetic field lines toward the polar regions. When these particles collide with molecules in the upper atmosphere, they release the light of aurora. Sometimes particles collect in Earth's magnetic field opposite the sun, then rush back into the atmosphere. This is called an auroral substorm and causes spectacular auroral displays. The color of auroras change depending on the energy of the particles and what kind of molecules they interact with. At the top of the atmosphere, some particles collide with atoms of oxygen, which then emit red light. In the lower atmosphere, oxygen molecules excited by collisions with solar wind particles generate green light, which is the most common auroral color. During the most powerful auroral storms, the nitrogen molecules in the air closer to Earth radiate in both red and blue light. These high-energy particle storms produce the most sensational colors. When the highest energy particles excite the bottom layers of our atmosphere, the light emissions mix and can produce a spectrum of colors, including this lovely pink. When it unfolds before your eyes, you may join others in the night to shout with delight. By now, you may be wondering about the best places to see the northern lights in person. We can determine where to observe aurora by learning more about what actually causes them. Let's take a look. Deep inside the Earth, the flow of molten iron in the outer core generates a magnetic field. Simply put, the Earth is one enormous magnet. The Earth's magnetic axis actually shifts gradually every year. Currently, it's slightly tilted over Canada. Near the poles, you will find the highest probability of viewing an aurora. This is the auroral zone, which circles the magnetic pole. Some of the best places to watch auroras include Yellowknife, Yukon, and Alaska in Northern America, and Northern Europe, including Iceland. As summer comes to an end, and the long twilight or white nights give way to darkness, and auroras begin to dance against the stars. As winter approaches, the sun appears to rise later each day, moving low on the horizon and setting soon after, beginning another long cold night. When reflected off the winter snow, the auroras seem to shine even more brightly. Auroras are constantly in motion. Scientists call the moving region of current displays an auroral oval. On a day like this, pale